Now let's take a look at the motion of hurricanes. Hurricanes, of course, like we talked about, need to form in tropical regions about 5 to 20 degrees off of the equator. Because remember, here at the equator, we get no Coriolis effect at all. So you can't have hurricanes form there. But a few degrees off, sure enough, you can get hurricanes forming there. Well, 5 to 20 degrees off of the equator, you are in the tropical latitudes, which means the primary wind pattern, going back to chapter 7, would be the trade winds. Here in the northern hemisphere, the northeast trade winds, or in the southern hemisphere, the southeast trade winds. So those are the wind patterns that the hurricane is first formed under. So it follows those trade winds, but as the hurricane moves along, it is also pushed towards the poles. And as it goes towards the poles, it reaches the mid-latitudes where the primary wind pattern are the westerlies. And so the hurricane turns around and moves to the east. So that is a very typical hurricane or tropical cyclone pattern, both in the northern hemisphere and in the southern hemisphere. So that's the typical pattern. Let's take a look at it by month. In June, one of the primary areas for cyclones to form are the Caribbean and the Gulf of Mexico. Not very often, not very likely, honestly. June's a very quiet month. Even though it's officially hurricane season, it's very relatively quiet. But if you get a storm that forms, it would likely be in one of these areas. In July, you start moving out into the Atlantic itself as some of the birthing places for hurricanes. By the time you get into August, you're getting these big tropical waves that come off of Africa, form storms. By the time they get halfway across the Atlantic, they have become tropical cyclones. And notice the motion very follows the wind patterns that we just discussed. In September, you get the exact same thing as in August, only now we're at the peak of hurricane season. The waters are the warmest in September, which means you're going to get far more hurricanes forming. Notice in August, it was primarily the Atlantic or the Caribbean. Same thing here, but now you get a little hot spots further up in the Atlantic, as well as the Gulf of Mexico starts to become a hot spot. As you get into October, the Atlantic starts to quiet down a lot, but the Caribbean and the Gulf of Mexico are still hot spots for hurricane formation. And as you get into November, November starts to quiet down, but you still get possibilities in here. So I have a figure here that shows all of the hurricane paths from 1985 through 2005. So you can see most of these storms are following that general path, going first to the west and then being caught by the westerlies moving to the east. But here's what I want to point out. Notice how many hurricanes we've had in the Atlantic. It pretty much covers the whole Atlantic basin, but you can see lots of spaces. It's not very densely populated. But over here on the west coast of Mexico, oh, it is absolutely packed. What's the difference? We always hear about these storms. Why don't we ever hear about these? Well, they're mentioned and they're talked about, but because these storms just move off into the ocean and then die off as they get into the cooler North Pacific water, they die out quickly. They don't affect anybody. Every once in a while they come out here and affect Hawaii, but very, very rarely. Most of the time they just move off into the middle of nowhere and they mean nothing. But where we really get a lot of tropical cyclones is here in the Western Pacific, near the Philippines and Korea and China. And these areas are, this is the hot spot on the earth. Here in the Atlantic, the United States has had now four, as of Hurricane Michael, 4 hurricanes that landed at Category 5 strength. Well, 2013, the Philippines in 1 year had 3 Category 5 equivalent cyclones make landfall in the Philippines in 1 year alone. They get far more storms over here than we do in the Atlantic, so we really have it easy. One last thing I want to point out on this graph, notice the South Atlantic. Nothing except for one lonely storm. This one storm happened in March of 2004, so the end of their summer. Notice the clockwise rotation of the storm. Now, this is Hurricane Katrina. It is the one and only named hurricane that we have a record of in the South Atlantic. Why don't we get hurricanes in the South Atlantic? Well, the water temperatures are much colder, plus you get a lot of wind shear. If you have wind shear, it normally tears the hurricanes apart. When you have colder water, you don't have the fuel. They don't really build to hurricane strength. Okay, we've talked about the typical paths. However, not all hurricanes follow typical paths. Here are a handful of storms that have followed really weird paths. I mean, here's Hurricane Pauline in the tropical latitudes that was moving to the east against the trade winds, and then it moved north. Hurricane Gordon here did the same thing. In the tropical latitudes, moved off into the east. Hurricane Sandy came and actually headed south for a bit and then moved north. So you get some really odd ones. What causes the odd paths? Hurricanes don't just follow the typical wind patterns, they also have to follow current wind patterns. So for example, here, you may have had, for Hurricane Mitch in 1998, you may have had a high pressure system sitting right here. What direction are the winds around a high? They're clockwise. So Gordon came up and the high pressure pushed it down, so it kept it further south, in fact pushed it further south. And then it came around that high pressure and came up. Just in the fall of 2019, we had Hurricane Dorian that had a very unusual path. It came along here, hit the Bahamas, and then stopped. Why did a hurricane just stop on top of the Bahamas? Well, it was because we had a high pressure system that was just sitting over here somewhere in the southeastern states, which was pushing that storm down, keeping it from coming up. So it just kind of pushed it and held it in place. That high pressure weakened, and when it weakened, the storm kept its northward track and moved northward and made landfall in the Carolinas.